can see the lesson. Why is the little thing? There we go. Okay, just waiting for Jonathan. Okay, so we're continuing to work with equations. Look, right here, nice desk right there for you. We're continuing to work with equations involving radical expressions that can be rewritten as a base to a rational exponent. So if I were to give you this problem, x to the 2/3 equals 4, and I wanted to rewrite this instead of using a rational exponent, using a radical, just for kicks, just to say we can, how would I rewrite x to the 2/3 power using a radical? Does anybody know? The base would be x. What would be the root index? 3, right? The root index is the denominator of the rational exponent. And remember that rule that says I can either put the squared on the inside or on the outside. Yes. Depending on what makes the problem easier. Now, there are different ways we can either approach this problem and solve it using rational exponents, or I can solve the problem in radical form. It doesn't make a difference because algebraically they're equivalent. So let's say I did leave it alone, and let's say I left it as x to the 2/3 power equals 4. Knowing what we know about our rules of exponents, when we have a base raised to a power, perhaps raised to another power, how to address that power to a power using that rule of exponents, what could I do to each side so that I can solve and isolate the x on the left-hand side? What could I do to each side? Beautiful. Raise it to the reciprocal power. Raise it to the reciprocal power. Because power to a power says keep the base and do what to the exponents? Multiply. So if we're multiplying a fraction times its reciprocal, what does that equal? 1, right? So this is really x to the first power, or just x on the left-hand side. Now, perhaps you would want to convert the right-hand side to radical form. And if I were to do that, it would be the square root of 4 raised to what power? Raised to the 3rd power. Does everybody see that? The root index again becomes, in this case, 2. And then we have the 3 out on side. So what is the square root of 4? 2. And if we cube that, what is x going to equal? X is going to equal 2 times 2 times 2, which is 8. Now, the interesting thing is, when we're taking the square root of a number, the square root of 4 in particular, is there not another number that when I multiply it by itself, that I get 4? -2. So technically, this could be -2 cubed, right? So the answer is plus or minus 8. Because -2 cubed is -2 times -2 times -2. So we have to keep in mind that when we're taking the square root of a number, we have to look at the positive number squared and the negative number squared for the radical, because that's plus or minus 2. So again, we want to pay attention to our root index. Our root index, which is kind of a part of that rational exponent, makes a difference. Because if the numerator of that rational exponent is even, we have to take into consideration plus or minus. However, if the numerator of the rational exponent of x is odd, we just look at the positive. Okay, so this is kind of going to tell us when to distinguish between when it's plus or minus and when it's just plus. So again, I can either look at it in this form, or I can look at it in the form where I've isolated x. So let's look at the difference again. When solving an equation of this form, the solution is x equal plus or minus k to the reciprocal of that, n over m, if m is even. However, x equals just the positive if m is odd. So as we did up above, we did it using radical form, but we also did using rational exponents. As Josh said, we just raise it to the reciprocal power. Okay? And we got that x to equal plus or minus 8. Let's try another example. If I'm looking at this problem, again, I want to solve for the value or values of x. Just like we wanted to isolate the radical expression on one side of the equation, perhaps we want to isolate the x to a rational exponent, if possible, on one side of the equation, which is equivalent to doing the same thing. So what might be the first step? Add 24 to both sides. Okay, so that is going to give me 8x to the 5/3 power equals 24. What might we want to do next to make this problem a little bit easier? Divide each side by 8. Excellent. So x to the 5/3 power equals 3. And then to isolate the x, if I want to address it in terms of a rational exponent, what would I do? Not multiply, but raise it to the power of 3/5. Yes, we're raising each side to the power of 3/5. So on the left-hand side, I have x. On the right-hand side, I have 3 to the 3/5 power. And let's just say that on a quiz or a test, it says represent your answer using a radical expression. How would I rewrite this using a radical? Yes. Or you could write it the 5th root of 3 cubed. Either one. Okay, what about the next one? What might you do first? Add 1 to both sides. Okay, so that's, I'm going to write it over here. X squared minus 3x plus 3 all to the 3/2 power equals 1. Now I've isolated that base raised to that rational exponent. So now if I want to address that rational exponent, what could I do to each side? Beautiful. Raise each side to the 2/3 power. So then that gives me x squared minus 3x plus 3 equals, what's 1 to the 2/3 power? 1. Now what is your gut telling you to do next? I'm sorry? You want to do that? Does anybody want to do anything else?
Factor.
But before I can factor, what do I have to do?
Make it equal to 0.
Set it equal to 0. So I'm going to subtract 1 from each side so that I'm just left with x squared minus 3x plus 2 equals 0. Then I have a beautiful quadratic trinomial on the left-hand side that I could factor easily. And what are my two factors? My factors.
Oh, x plus x minus 2x.
Perfect. Zero product property says I can set each of these equal to 0. So what are my two values of x? 2 and 1. Are they both valid? You tell me. 2 is not?
2 is.
2 is. Yes, that's our solution set. Now, you may get problems that look a little daunting, but as we kind of touched on last semester, we can rewrite them in a different form, making it easier. Okay? Now, if I were to look at this original problem, I would notice that the degree is what? 4. So since the degree is 4, how many solutions am I looking for? 4. At the end of the problem, I need to see if I have 4 solutions. Again, they may not be 4 unique solutions. Some of them may be repeated, but I am looking for 4 solutions. Now, if I look at this, I see this x to the 4th. I see this x squared. I see that x to the 4th is x squared squared. So perhaps at this point, I want to go ahead and I want to introduce a new variable u, let u equal this. If I write it in exponentially descending order, and I see this is a nice little trinomial that's going to be easily factored, I can let u equal this. So let u equal x squared. So that means u squared is x squared squared, right? Which is what? U to the 4th. I mean, I'm sorry, x to the 4th. Right? So I can now, once I've introduced this, I can rewrite this problem using u. So if I were to rewrite this problem using u, x to the 4th is u squared. Oops. X to the 4th is u squared minus 13u plus 36 equals 0. Do you see how I've introduced a new variable to make this problem easier? Now, this is a beautiful little quadratic trinomial. I can factor that. What are my 2 factors? U minus 9 and u. Beautiful. Zero product property says I can set each of those factors equal to 0. So I get u equal 9 and u equal 4. But I'm not solving for u. I'm solving for x. But I know what u is. U is x squared. So I can go back and now replace that u with x squared. And I can replace this u with x squared. Because remember, u is x squared. We defined it that way. So now if I want to solve for x, what am I going to do to each side here? Square root each side. And I'm going to do those for each of those original factors. So then I get x equals what? Really? Plus or minus 3, right? The square root of 9 is plus or minus 3 because 3 squared is 9, negative 3 squared is also 9. And then x equals what for this one? Plus or minus 2. So x can equal negative 3, negative 2, 2, or 3. Look how many values I have of x. Well, we said the degree was 4. I have 4 solutions. Of course, you'd want to check it, but everything is just going to be, we're not going to get anything that's going to cause any problems. So that is our solution set. Do you see why? Yep. Okay. Yeah, that's fine for, yeah. You can either write this, or this. Unless the question says represent your answer as a set. Okay. Moving on. Again, you may look at this and originally say, oh, I just don't know about that. And again, negative exponents. but it kind of looks like it could turn into a quadratic trinomial. And it can, because if I let u equal what? Beautiful. X to the negative 1 power. So that means u squared is what? X to the negative 2 power. So I can rewrite this as u squared minus u minus 6 equals 0. And look at that quadratic trinomial on the left-hand side of that equation. What are my two factors? Excellent. Zero product property again tells us to set each of those factors equal to 0. Solve for u. I get u to equal 3 and u to equal negative 2. Am I done? No, because what is u? X to the negative 1 power. And we know how to address negative exponents, don't we? How could I rewrite x to the negative 1 without, just for kicks, without, do we remember how to write that without a negative exponent, just for kicks? 1 over x. 1 over x, right? Remember how we do that? Now, you may not want to do, there's so many, there's different ways I can approach this. You can either use what we did before by raising it to that, trying to get x to the 1 power on the left, or you can rewrite this immediately without the negative. It doesn't matter which route you go. What would you like to do next? You tell me. Yeah, but how are you getting there? That is absolutely correct, but how are you getting there? What algebraically, what are you doing to get to that point? How am I going to get x on the left here? Okay, so what am I raising each side to? What power? How am I going to get an x to the 1?
Negative 1.
Negative 1, right? Power to a power says I keep the base and I multiply the exponents. For me to be able to get a power of 1 for x, I'm going to have to raise the left-hand side to the negative 1 power. Does everybody see that if I'm using that rule? So if I'm raising the left-hand side to the negative 1 power, I'm raising the right-hand side to the negative 1 power. So that means x equals what? How do I address that? 1/3. Okay. So if you do it the same way, I mean, there's many different ways we could do this. If you didn't see that and you immediately change this to 1 over x, that's fine. You would then multiply each side by x and you'd get 1 equals negative 2x. Then you'd have to divide each side. There's many different ways algebraically to approach these. And there are your two values of x. Okay, let's look at the next one. May be daunting at first, so let's go ahead and introduce u. What do we want u to be? X to the 1/5 power. Okay, so obviously u squared would be x to the 2/5 power. So I can rewrite this as u squared plus u minus 6. Much easier problem to solve. Factor, what are my two factors? Okay, so that means I get u equals negative 3 and u equals 2, but I know what u is. It's what we said it was, x to the 1/5. That's how we defined it. Now, how am I solving for x? Because I need at the end of the problem x equaling a number, x equaling a number. What would you like to do? So what is x equal? X equals negative 3 to the 5th power. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. 5 times, repeated by multiplication 5 times. So what is that going to equal? It's not like anything. It's exactly what?
243.
Beautiful. Negative 243. Okay. And then over here I have x equal 2 to the 5th. 2 times 2 times 2 times 2 times 2. So x equals? And those are my two values of x. So when you get the problem, ask yourself, is there a way for me to make this an easier problem to solve? Let's try another one. In my heart of hearts, I know I can rewrite this as a quadratic equation by letting u equal what? Well, this is a quadratic, but we can make it easier. Let u equal x minus 10 over x. Let's go ahead and let's take all of that, right? I want to make this an easier problem. So I can rewrite this as u squared plus 6u minus 27 equals 0. If I factor the left-hand side, what do I get as my two factors? U. Yes. FOIL to check, right? So u equals -9, u equals 3. I know what u is. What could I do to make this problem easier? I don't. I mean, I can sense the unsettling feeling of y'all having that x in the denominator. What could I do to this equation so that I don't have an x in the denominator? Multiply every single term, meaning on the left-hand side and on the right-hand side by x. I'm multiplying the entire equation by x. So what is that going to give me on the left here? X squared minus 10 equals -9x. Now what do you want to do with that? Okay, so add 9x to each side, setting it equal to 0. Okay, so I have x squared. I'm going to put it in exponentially descending order with respect to x. That's a nice little quadratic equation again that I can factor. And what are my factors? So x equal 1 and x equal -10 are the two solutions to this part. But I have to come back over here and do the same thing with this one. Multiply the left-hand side by x and the right-hand side by x. So what is going to be the quadratic equation here? Minus 3x minus 10. Does everybody see how to get that? I did a couple steps at once there, but stop me if it doesn't make sense. Okay, factor that. And what are my two factors? Beautiful. So that gives me x equal 5 and x equal -2. There's my solution set. And again, if you're writing it as a set, don't repeat any numbers and write them from smallest to largest value.
Why is it, why are there 4 answers and split the 3 of the equation?
Well, because if this were a binomial and I were to expand this, FOIL that, I'm going to get an x to the 4th term. Yeah, that's an excellent question, Josh. Excellent question. Any questions on this? Okay, now the next thing that you are going to be doing, so you have on my math lab for this is 1.6. What I would like you to do next, and let me see, let me go to Canvas and see if I can show you the assignment this way. If it will load. It's not gonna let me. Let me see if I can get to it through modules. Ugh, heaven help me. This. It's called decoding radicals. Okay. So for those of you who are at home, go to decoding radicals. It is this worksheet. Okay. So you have 13 radical equations. I'm gonna give it to you if you're in the room. Okay. 13 radical equations. So on a separate sheet of paper, you're going to write number 1, the problem, work it out. Number 2, problem, work it out, etc. For all of them. Once you get the answers for each of those and have boxed them in a nice orderly way, I want you to find the answers here. Then you're going to substitute in the corresponding, like if you go to number 12, what did you get for the answer? Which one is it? Put it in here. And it's going to be a cute little message you're decoding. Once you finish this, scan it, upload it to the assignments in Canvas. This is another 5 points. Okay? So this is an assignment. You technically should be able to finish this in class today. Okay? However, I don't want to rush you. So if you don't finish, of course, it's going to be due next Monday. We don't have school Monday. It's due Monday. It's not going to take that long to do it. Then once you finish this, because some of you may finish this very fast, you can work on your My Math Lab, the 1.6a if you haven't finished, and 1.6b. So let's work on those. We have things to do. Let's make sure that we're getting them done. We want to start the semester strong. We don't want to get behind, have holes. Let's start the semester strong. Okay? Any questions?
Yes, I have a question. I don't see it under assignments, nor do I see it under the modules.